So today's class will continue exploring more about the factors of the number, okay? Now, I'll begin with two specific number, which is 30 and 24, okay? Now let's do number 30 first. I want you to go to the chat section and then think about any number that is a factor of 30 or is divisible by 30 that immediately pop up your head, okay? So go ahead, type it in. Okay, I see a lot of 1 and 30 as pretty obvious, and I'm going to write it down for you. And I saw 2, 3, and 10. I see 10 as well. Ooh, 5 and 6. That's amazing as well. All right. Any left? Is that all? 1, 2, 3, 5, 6, 10, and oh, 15. Yes. 15 is also divisible by 30, okay? Now, let's do number 24 and type in the chat section as well. Okay, see 1 and 24. 2. I see 2. I see 3. I see 4. And I also see somebody type 6 as well. And 12. All right, 1, 2, 3, 4, 6. Are we missing any number? Oh, 8. Okay, so we have 1, 2, 3, 4, 6, 8, 12, and 24. Hopefully that's all we need, okay? All right, so now today we have a new concept of the factor is called greatest common factor. Greatest common factor. So by definition, when we say the greatest, that means we're looking for the biggest number, okay? So I want you to look at the list that we just did the factor of the number 30 and 24. So which number is the largest? I heard you say number, yeah, it is number 6. I'm going to highlight this for you. So 6 is the greatest we have. So there's no other numbers is other than 6 is repeating, okay? And then yes, so 6 is so in this case, 6 is our greatest common factor for number 30 and 24, okay? Now here comes the critical thinking. If you want to find all the common factors of, let's say, 1024 and 986, it's still easy to listen all. I see people put thumbs down. Yeah, of course not, because the larger number will take you a lot of time to list all of them, okay? So in this class, I'm going to teach you two methods that you can find greatest common factor without listing all the numbers one by one, okay? So ready to go? Okay, let's move it, all right? Let me clear my drawing. Now, I'm going to still use the same number 30 and 24 just for you to get prepared ahead, okay? So the first method is called prime factorization. So what I mean about factorization is that I'm going to use the same two numbers as well. Now, think about a prime number. Okay, I see allow you think about 2. So I will say 2. Yeah, 2 is one of the most common prime number you can think about. Okay, so I write down 2 over here, and then what number should be put on over here? What do you think? The number we put it here is a number that can be is both divisible by 2 by what's left, which is 12, because 2 times 12 is 24, okay? Now, I'm going to circle the 2 because 2 is a prime number. Now, 12 is not. So what else can be divided by 12? Okay, I see 3 and 4. Okay, so 3 is a prime number, yes. Now, 4 is not, because 4 can be also divided by 2 and 2. Okay, so now I have 2, I have 3, I have 2, number 2, and I'm going to circle it because these are all the prime numbers I have. It's a factorization of 24. Okay, so just going to show you that there's a reason why I'm circling this number afterwards. Okay, now let's do number 30. Okay, 3 and 10. Okay, that's a good one. And then 3 is a prime number, so we circle it. And 10, we can still split into 2 and 5 because 2 times 5 equal to 10, okay? All right, 2 is a prime number. Is 5 prime number? Yep, there you go. So this is what we call prime factorization, is that you decompose or split into numbers that is prime left, okay? So now what we're going to do next is that we're going to write down a little bit more clear, so you're going to see how prime factorization works, okay? So we have 2 3 times, so 24, so that means 24 is also equal to 2 times 2 times 2 times 3, okay? And 30 equals to 2 times 3 times 5, okay? Now, what we're going to do next is that pay attention to the list of the prime factorization of 24 and 30. And then what we're going to do is that we're going to find what do they have in common, okay? So we have a common of 2, okay? Now, we do not have any 2 left for number 30, so we do not highlight the rest of the 2 on the 24, okay? But we do highlight number 3 because 3 and 3 are both the prime factorization of 24 and 30, okay? And we do not highlight number 5 because 5 is not a part of 24, okay? Now, in summary, the greatest common factor, or shown as GCF, will be whatever number is being highlighted on both number 24 and number 30. So in these cases, 2 and 3, what we're going to do is we multiply what has been repeated. So that also gives you the same result of what we had earlier, which is 6. Okay, so this is prime factorization. And now I'm going to show you the other method, which is, let me clear your screen, which is called the ladder method. Okay, now the ladder method is kind of like you're going to draw a ladder. Yeah, that's correct. So you draw a ladder like this, an L-shaped ladder, but make sure this side is shorter than this one, okay? I'm put 24 and 30 in the middle. Okay, now think about a prime number on the left side. Okay, you think about 2 again. So now, if I put 2 over here, what we're going to do is we're going to divide these two numbers by 2. So 24 divided by 2 gives you 12. And 30 divided by 2 gives you 15. Yes. Okay, now 12 and 15, one number can be both divisible by 12 and 15. 3. Yes, 3 can be both divisible. So because 12 divided by 3 gives you 4 and 15 divided by 3 gives you 5. Now, are there any numbers can be both divisible by 4 and 5? No, we do not have that. Yeah, we do not have. So, which means when we have the number, when we left with 2 numbers that cannot be divisible by any numbers other than 1, we just stop over there. So this is our final step. Now, finally, what we're going to do is that we go 2 on the left side of the number, we get 2 and 3 again. So same strategy, the greatest common factor, which is GCF, you divide, you multiply whatever the number on the left side, that also gives you 6, right? So in summary, regardless using ladder method or the prime factorization method, what you're going to do is that the GCF, which is the greatest common factor, what we're looking for is the largest number that can be by each one of given number without remainder. So in our example, 24 and 30, because numbers, the number we can both divisible, they are 1, 2, and 3, but the largest one, which is 6, 6 is the largest one, so there are no other numbers can be divisible other than 6, okay? So So this is the example of greatest common factor, and I will see you next round.